Hi there and welcome to my channel. My name is Erfan and I'm here with a very interesting and challenging math Olympiad question for you guys. So I suggest you to pause the video first and try it out yourself before we dive into the solution. All right, so we're given a solid shape as you can see in the diagram, and it has 12 regular pentagonal faces, the other faces being either equilateral triangles or squares. Each pentagonal face is surrounded by 5 square faces, and each triangular face is surrounded by 3 square faces. John writes 1 on each triangular face, 5 on each pentagonal face, and -1 on each square, as you can see right here. So the question is very clear. What is the total of the numbers written on this solid shape? Now, if you want to start counting the squares, the triangles, and then insert these numbers inside each one of them and count the total number, that would be a very wrong approach. After all, there will be so many overlap. For instance, this triangle is shared between all these 3 pentagonal. So counting them would be a very difficult task to do. However, what I came up with, and I would like to know whether you did the same thing or not, is that since each pentagonal is surrounded by 5 squares, which is shared by the neighboring pentagonal, I divided it into 2 equal regions, and as a result, they are not overlapping anymore. Now, you might ask, what's the advantage of that? Well, if one square is -1, so half of the square is -half. And each pentagonal is surrounded by 5 -half. And since I have 12 regular pentagonal, so 12 times 5 rectangles, and each rectangle, the value is -half. So that's gonna be a -30. And I shouldn't worry about the squares anymore because I have already split up the square. Now for the pentagonal, it's gonna be very easy. I have 12 distinct pentagonal. They have nothing in common, and each one has a value of 5, and that's gonna be a total of +60. Now I have to worry about the triangles. I'm gonna use the same approach. I'm gonna split each triangle into 3 equal portions, and each one of the portion I'm gonna give it to one of the pentagonal that its neighbor with the triangle. So that means if the value of one triangle is 1, so you divide it by 3, so 1/3 goes to this pentagonal, 1/3 goes to this, and 1/3 goes to this. Now if you look at each pentagonal, it's surrounded by 5 triangles. Now instead of counting those 5 triangles, let's say it's surrounded by 5 tiny triangles, which the value is 1/3. So I have 12 pentagonal, which each one of them has 5 tiny triangles, and then each one of those tiny triangles carries the value of 1/3, and that's gonna be 4 times 5, which is +20. So all I have to do is just to add these numbers, and I get -30 plus 60, which is +30, with 20, that is +50, and that is answer choice B. Thank you for watching the video. I hope you got the same answer as me, and please share your answer in the comment. If you used a different approach, I'll be more than happy to check that out. Please don't forget to like and subscribe. I'm gonna see you guys tomorrow with another Math Olympiad question. Thank you.